everybody. Welcome. My name is Heijden. I'm the co-founder of the Coalition of Health Professionals for Regenerative Agriculture. Today we have our peer-to-peer session where we come together to look at studies on these subjects and discuss them. This is one of the ways that we promote education within our organization. And today the paper that we're going to present is called Soil Microbiomes and One Health. It was published last August in Nature, so it was quite a popular paper. It had a lot of attention, I think, for us in Regen Ag. Everybody shared it, everybody was talking about it. It was a very important paper for us and for One Health. So I'm going to start presenting it. The abstract talks about, then just gives some concepts. The concepts of One Health highlights the human health, and it's not isolated but connected to the health of animals, plants, and environments. In this paper, we're going to see and they're going to demonstrate that soils are a cornerstone of One Health and serve as a source and reservoir of pathogens, beneficial microorganisms, and the overall microbial diversity in a wide range of organisms and ecosystems. So in the introduction, it talks a lot about what is the soil microbiome and the microbial communities that are in it. We know that a wealth of studies now demonstrates that microbial communities are associated with plants, animals, and humans function as a second genome, so a second DNA, and thus drive the fitness and performance of almost all of organisms on Earth. A growing number of studies also suggest that microbial communities of different organisms are interconnected and form a circular loop. However, compared with plant, animal, and human health, the importance of soil microbiome and soil health has received less attention amongst One Health researchers until now. This study assesses how soils can be the source of microorganisms for other ecosystems and identify the microbial taxa. The taxa are the classification that are shared, classification of bacteria that are shared between the different One Health components. This study will evaluate factors that regulate soil microbial contributions to One Health and also analyze these contributions in the light of environmental perturbations and dysbiosis, and discuss how soil microbiomes can respond to such changes. So the importance of soil microbiome in the face of climate change, and also in the face of a westernized diet that's been causing us a pandemic of dysbiosis, which is an disbalance of our intestinal microbiota. So the first topic is soil as a source of microbiomes. So for our carbon mass on the planet Earth, for the total carbon mass, we have 0.3% being from animals, 1% being from archaea, which is a type of very ancient bacteria, 2% of fungi, and 15% is bacteria. So soil harbors the most diverse and complex microbiome on Earth, and 1 gram of soil has often more than 0.5 micrograms of microbial biomass carbon, and also over 50,000 species. Consider soil as a major source of microorganisms in terrestrial ecosystems, and thus the foundation of One Health. The dominant players of each microbiome compartment, soil, plant, animal, and human, vary considerably, but however, humans and animals have shared microbiology with soil. We're going to delve a lot into this and how we are sharing these microbes with all of the components of One Health throughout the paper. Specialized members of soil microbial communities assemble in the plant rhizosphere and get preferentially recruited into the roots, and as a result, plants receive a subset of the soil microbiome. What does that mean? A plant rhizosphere is the area of the plant just around the roots. So in the rhizosphere of the plant, we will have a lot of microbes, and as a result, this plant will absorb these microbes inside, and this will also colonize the plant microbiome. Bulk soil is the most important contributor to plant endophytic microbiota, contributing more than 2/3 of the bacterial and fungal diversity. What is the planto-endophytic microbiota? So if we separate endophytic, endo, it's inside, exo, it's outside, exit, and phytic is phytoplant. So the microbiota inside of the plant, it's being highly altered and influenced by bulk soil. And then the study goes to talk about geophagy. Geophagy is the consumption of soil, and this happens in animals and also in humans. Okay, so if we talk about grazing animals, grazing sheep can eat up to 400 grams of soil per kilo of body weight, and dairy cows up to 350 kilos of soil per year per cow. Estimates suggest that up to 3% of the rumen microbiome of sheep and cattle can be contributed by the ingested soil. And then the study goes to talk about all of the different examples of how microbiomes of soil can interact with animals and humans. So soil-dwelling mice can directly acquire microorganisms from the soil that can alleviate inflammation and allergic reactions. The skin microbiome composition of farm animals is also linked to the soil microbiome. Different bacterial species are connected with high-performance poultry farms. In cattle farms, soils can be a recipient of antibiotic-resistant genes from the rumen microbiome. So we're going to talk a lot about the antibiotic resistance, and also last week, Christina presented a paper on soil microbiome and antibiotic resistance, which I really recommend that you guys check it out. Human geophagy has been reported in many parts of the world, including Asia, Sub-Saharan Africa, Latin America, and the Pacific Islands. Soil types, clay loam soil versus loam soil, are correlated with the nasal and oral human microbiomes. So through inhalation or even eating soil, we are also being inoculated with the soil microbes. Higher microbial diversity, which has been linked to reduced risk of hospitalization for infectious and parasitic diseases in Australia. And the oral, nasal, and skin microbiomes of farm workers are associated with the soil microbiome composition of their own farms. So this is the famous picture. I'm sure you've seen it. It went all around. This picture is very important because it really shows in a very easy way to understand how we are, all of the components of One Health, the soil, the humans, plants, and the animals and insects, we are sharing microbiology. So if you see on the table, we will have different taxas of bacteria. And on the circles around each component, we will see these taxas of bacteria. So for example, if we look at the green one, which is Bacteroideae, we can see that all of the circles contain the green. So this taxa is being shared amongst all of them. And there's other colors like brown or orange. So it's all being shared, or also between 2 or 3 components. And the soil, it's basically the bulk for all of these microbiomes. So then it carries on to share with the others. So soil microbial contributions to One Health. Now the paper is going to go through all of the different things that influence soil microbiomes. So it starts with soil health. There's plant health, soil health, human health, and there's another one. It will come afterwards. So soil health. The definition of soil health is the capacity of soil to function as a vital living system, to sustain plant and animal productivity, to maintain or enhance water and air quality, and promote plant and animal health. The degradation of soils owing to land use change, erosion, compaction, and pesticide contamination has highlighted the urgent need for sustaining the ecosystem services of soils, leading to a growing interest in the practice that can maintain healthy soils. Crop diversification and reductions of synthetic pesticides, mineral fertilizers, and intensive tillage can improve soil biodiversity and soil health. Soil microbial communities can have direct and indirect influences on a multitude of processes, including nutrient cycling, organic matter dynamics, soil structure, carbon transformations, and carbon sequestration. Microbial biomass complexity and the presence of key microbial groups are associated with a stable pool of soil carbon, making microbial parameters essential for our predictive understanding of soil carbon sequestration. What does it mean? We need microbes to sequester carbon. We need a healthy soil. We need healthy soil microbiomes in order to have diversity of plants, insects, trees, and all of the elements that we need to create this the stable pool of soil carbon and then be able to sequester this carbon. However, whereas the physical and chemical indicators of soil health have been emphasized in the literature, the soil biological indicators have received very little recognition. Plant health. Out of the approximately 29 essential elements for plants, 18 are obtained from the soil, and soil microbial communities play a central role in delivering these elements to plants. The rhizosphere microbiome, so the microbiome that is on the rhizosphere, strengthens the metabolic repertoire of plants and facilitates a range of processes, including seed germination, seedling establishment, nutrition, water uptake, growth promotion, pathogen suppression, stress tolerance, and hormone regulation. Indirectly as well, microorganisms in the rhizosphere can influence important function traits such as leaf area, leaf longevity, leaf nutrient levels, and shoot-to-root ratio. Soil microorganisms can shape the structure, composition, and functioning of a plant-associated microbiota. And microorganisms are responsible to acquire 80% of plant nitrogen and 90% of plant phosphorus. One of the most well-known examples of plant beneficial microorganisms are the mycorrhizal fungi. We all heard about it, which form symbiotic associations with nearly 90% of land plants, including many crops. Plants obtain water and essential micro and macronutrients from mycorrhizal fungi and supply up to 1/4 of their photosynthase in return. So the plants, many times they can't break down large molecules, and therefore they will outsource this to microbes. So the microbes, they stay around the root in that rhizosphere microbiome. They're breaking down all of the molecules, giving in as a more bioavailable form to the plants, and in return the plants will make photosynthesis and give the photosynthate, which are normally sugars. So the exudates that we talk about. So the plants is going to put these exudates, these sugars, back to the microbes to feed them. And therefore, they form this symbiotic relationship. Mycorrhizal fungi can enhance the growth of a wide range of crops by up to 50%. Not all soil microorganisms promote plant health, and there are numerous soil-borne plant pathogens. Disease-suppressive soils are soils that, owing to their microbiome composition and activities, prohibit pathogens from establishing or greatly reduce pathogen damage. This is just like the human gut microbiome. We know that our immune system is highly connected to our digestive system. When we have a strong digestive system, a strong microbiome, we have a stronger immune system as well, and it's the same for the soils. If a soil is healthy and has a healthy microbiome, it will have a much bigger capacity to fight against pathogens and to fight against opportunistic fungus or other plagues that come. Okay. Animal and insect health. The soil environments can be a source of animal microbiomes and microorganisms that animals ingest through food. So not just by touching and getting contact, but also ingesting the soil, as we talked about before. Studies show that insects acquire these microorganisms vertically from offspring, and also by feeding on plants and being exposed to microorganisms originating from soil. Soil microbiomes can even influence the health and social behavior of soil-dwelling microorganisms. This is very interesting. So me, my husband, and a friend Etienne, we run the Regenerative Agroforestry podcast, which I really recommend everybody to listen. But we have a deep dive on animal social behavior with Dr. Lindsay Wistens. She's a livestock researcher, and her research is on animal welfare and having a landscape that has trees, that the animals are less stressed, they have more water, and they're happier. Influences a lot the social behavior of these animals. And so it's very important that we see that not just because the landscape has more trees, but because the soil is healthy, then these animals will also be influenced in their social behavior. It's very, very interesting. For example, a recent study found that the abundance of the butyrate-producing bacterium, Kineotrix alizoides, in soil microbiomes was correlated to reduced anxiety in mice exposed through dust. And she's talking about cattle. So with mice, it's normally on the labs, and she works on farms. Insects can also acquire soil microorganisms that depolymerize insecticides, making them insecticide resistant. A diverse soil microbiome can have positive implications for the gut health and mental health of soil-dwelling mammals. And we know this as well for us. We have plenty of studies connecting mental health, the gut-brain axis, to microbiome health. Animal diseases can also directly develop from pathogen sources in soil, and some of these pathogens can also directly or indirectly, as zoonotic disease, infect humans. Like we had had a COVID pandemic. Research is still unclear about which fraction of soil microbiota ends up in herbivores or carnivores, and how it affects the health of animals. Human health. Human health is intimately connected to soil health. Ingestion of soil is used to supplement a nutrient-poor diet, is used also as a detoxifying agent to make products more edible, and also it is used as medicinal reasons for GI treatments. People with more exposure to natural environments are less likely to suffer from allergic reactions, which may be linked to soil microbiomes and the inhalation of soil particles. And then we go to talk about the hygiene hypothesis. And the hygiene hypothesis says that, basically, if you have a lot of hygiene, you over clean yourself or your house, or you use a lot of drugs and antibiotics, you will have a smaller, or let's say defective, I don't know if that's the word, immune response. You will have your immune system being less stimulated, and therefore it will be weaker. And that is correlated with our global rise of allergies, autoimmune conditions, asthma, atopic dermatitis, hay fever. We're living in cities, we're living in very closed, clean environments. We're not being exposed to nature anymore. Our food is dead. We're eating food that has antibiotics and all sorts of things. So, and that goes not against, but it faces the biodiversity hypothesis, which is completely the opposite. And it shows that kids growing farming environments, they have reduced allergic sensitivity because they are being exposed to higher microbial diversity. So they have a stronger immune system. So together, these hypotheses highlight the importance of natural environmental microbiomes for human health. Soil microbiomes regulate the cycling of essential elements in plants and also the health of all plants. Humans can only synthesize half of the essential amino acids themselves and depend on food intake for the remaining amino acids and essential vitamins. Plants only produce small amounts of secondary metabolites, But beneficial microorganisms associated with them can enhance the production, including different omega-3s, polyunsaturated fatty acids, linoleic acid, L-carnitine, choline, and sphingomyelin. Therefore, we talked about it before, the plant can only synthesize a little bit of these secondary metabolites, and the microbiome around the roots, they increase this production. And therefore, why is it important that we have a healthy soil? We will have higher contents of omega-3s, for example, or different other nutrients into our food. Soil microbiomes are essential for food security when we talk about local and global level. Soil microorganisms mediate a wide range of environmental processes and soil ecosystem services, including purification of drinking water, stabilization of soil aggregates, carbon storage, and the production of greenhouse gases. Healthy soils are linked to a good soil structure, optimal nutrients, and organic matter levels. Soil microbiome have a demonstrable impact on plants and animals consumed by humans, and by doing so, soils indirectly influence human health. More than 300 soil fungal species are known to cause human disease. For example, the Xerolium rostratum caused the fungal meningitis outbreak in the United States in 2012. And some proteins can also cause human parasitic diseases such as diarrhea and amoebic dysentery. Hookworm infections affect millions of people and causes more than 10,000 annual deaths worldwide. And E. coli causes 73,000 infections per year in the US, and it can persist for more than 90 days in the soil. It is still unclear what proportion of the human microbiome is directly or indirectly linked to the soil microbial reservoir. This is the second picture of the study, and this is how the soil microbiome influences one health, so all of the components. So has a great impact on plant growth, protecting against plant pathogens, soil health, and also mitigating climate change, protecting against soil-borne pathogens, influencing animal social behavior. We also have geophagy, and dust exposure that make the soil microbiome enter us and animals. And in the soil, we can also find antibiotic-resistant bacteria. So these are influencing factors of one health. And the edaphic factors, these are factors related to soil properties, okay? So soil temperatures, pH, moisture, redox status, organic carbon content, and spatiotemporal heterogeneity are the major drivers of soil microbial communities with feedback on their contributions to the ecosystem, processes, and one health. Soil pH is a key predictor of microbial community structure and composition at field to continental scales. The ability of mycorrhizal fungi to forage for nutrients and deliver them to plants is directly linked to soil pH. And soil organic matter has an overall positive effect on soil microbial diversity and community composition. It's linked to the cycling and availability of other nutrients. Global change factors. One of the strongest consequences of global climate change is increasing occurrences of drought. The decline of mycorrhizal fungi of trees because of the warming and droughts can cascade below ground and accelerate soil organic matter decomposition, reduce soil organic carbon content, and alter ecosystem biogeochemistry. The effect of elevated CO2 can be more complex, and rising CO2 can differentially alter microbial ecophysiological strategies with divergent effects on different functional groups. So the elevation of CO2 is going to affect the microbial physical characteristics in a way that it varies a lot, and we don't know yet how so much. The proportional abundance of soil-borne pathogens may increase with rising temperatures, alter humidity, and precipitation. Warming and alter humidity may enhance plant disease owing to a microbial loop again, but in the other direction. And then it goes to talk about this recent meta-analysis that found the net effects of global change factors like warming, elevated CO2, drought, fertilization, land use, etc., on microbial alpha diversity are highly variable, with rare microorganisms being more affected than the dominant taxa. What does it mean? We have in different microbiomes the dominant taxa, they will have the bigger population of bacteria, and we have these rare microorganisms they are in smaller quantities, but they are extremely important for the health of this ecosystem. And the droughts, the rise in temperature and CO2, etc., affects a lot these rare microorganisms, and that's really damaging to ecosystem functioning in general. So antimicrobial resistance, this is a very hot topic. Soil microbial communities and their contributions to One Health are further threatened by chemical pollution, including microplastics, antibiotics, and pesticides. More than 700,000 people die annually from antimicrobial resistant infections, with a projection to up to 10 million by 2050. So this is the very alarming data. As much as 32 tons of third and fourth generation antibiotics are annually used for meat and dairy industries. And this is where I can't emphasize enough how regenerative agriculture, how holistic management and rotational grazing is so important for us to shift from a very threatening, damaging industrial way of producing livestock, and we really need to switch that production. Large use of antibiotics has led to the spread of antimicrobial resistance, AMR, genes, and soil is one of the sinks for AMR. EMR genes can be detected 90 days after application of EMR-contaminated manure in soils and can be transferred from manure-amended soils to vegetables. So antimicrobial resistance genes, they're being transferred from animal to soil, to plants, to humans. Land use intensification. The total area of cultivated land worldwide has increased by more than 500% in the past 5 decades, with a 700% increase in fertilizer use and a several-fold increase in pesticide use. Such intensive practices can reduce the diversity and complexity of microbiomes and negatively influence beneficial microorganisms in roots and soils. Land use intensification can cause homogenization of soil microbial communities with the dominance of just a few taxas and decreasing the overall diversity. The use of agrochemicals has increased by more than 40% in the recent years, with as much as 1.2 million tons of active pesticide ingredients being used annually. Synthetic pesticides are widespread in soils, and residues can be detected even after 20 years of organic management. Pesticide residues had negative association with the overall microbial mass and impaired the nutrient uptake machinery of beneficial mycorrhizal fungi. Pesticide has a direct connection to lower nutrient density in plants and crops. One Health, dysbiosis, and soil microbial diversity. Okay, let me just have a sip of water. The positive effects of soil microbial diversity are explained by the fact that different microorganisms provide different functions. The more you have, more functions will be fulfilled because you have a big diversity of people or bacteria doing different things. The resistance and resilience of soil microbiomes to disturbance is expected to increase with microbial diversity. The disruption of microbiome homeostasis, which is dysbiosis, can cause impaired soil plant and human health, and this is often linked to reduced microbial diversity, indicating the importance of biodiversity. So here is really highlighting the fact that microbial diversity is very important for a microbiome, and how this will then leave you in a state, or the soil, or you, or whichever microbiome you're talking about, in a state of dysbiosis. So there's a disbalance on the microbiota, um, but then in the end he goes to discuss really if microbial diversity is really a factor that it's important or not. So for here now we understand that microbial diversity is really positive, and that's what we want within a microbiome. Maintaining a healthy state requires eubiosis, so against dysbiosis, is biosis in a state of balance of soil microbial communities, which is typically associated with high diversity and uniformity of overrepresented microbiota. However, considering the remarkable dynamics and inherent complexity and instability of soil microbiomes, the task of identifying a healthy state can be daunting. We don't know so much about how soil microbiomes really work. We have an idea of what is healthy and what is not. We can have some factors that are classified as healthy and some factors that are not. But to categorize a soil as healthy or not, a soil microbiome as healthy or not, it's very hard because it's very complex. So we are in science a bit not there yet. Okay. Importantly, a healthy microbiome, it's not by definition diverse. Although various studies report a positive link between soil microbial diversities and components of One Health, there are also examples of no relationship and context dependencies. For example, many of the taxa in the gut microbiome belong to Firmicutes and Bacteroidetes, which together represent nearly 70% of our total microbiota. And the dominance of a few taxa is adequate for usual functioning. Indeed, understanding the biology of a healthy microbiome states a major bottleneck. So even though we have 70% of our gut microbiota just with two taxas, we can still count on the beta diversity, not the alpha diversity, the beta diversity, which will be then the diversity of microorganisms within these taxas. Okay, so we're this study highlights that microbiome is woven into One Health because the health of each of its components is determined by microorganisms. We also demonstrate that soil microbiomes directly and indirectly influence plant, animal, human, and environmental health. Classification, urbanization, landscape simplification cause homogenization of the soil microbiome and reduce soil microbial diversity. Soil microbiomes in urban sites compared with rural sites contain more antibiotic-resistant genes and genes associated with human pathogens. So this is also very clear, very easy to understand. In urban areas, we have a very different exposure to microbes than in rural areas. Animal livestock consumes the majority of the world's antibiotics, and threats of antibiotic-resistant bacteria. They can be distributed via seepage. Seepage is like leaking gas, liquids and stuff into the environment, or manure to the environment. Viruses may play a much more important role in soil communities than previously thought. Chemical pollution is widespread. The soil microbiome is exposed to many chemical contaminants, including antibiotics, microplastics, heavy metals, and pesticides. Pathogen invasion is hampered, it's stopped when soil microbial diversity is high. However, it's still unclear whether impoverished microbial communities are less resistant to invasion or not. Finally, whereas this state of above ground biodiversity is easy to monitor and already very reported in literature. Underground processes are more difficult to study and far less understood. In the view of the importance of soil microbiome in determining one health and the health of all of its components, plant, animal, human, and ecosystem, we recommend that governments initiate and support systematic monitoring tools to investigate the trends, threats, and long-term developments